our next new graph. But nothing's new because it's the same thing. All right, so it's not square root today. What kind of root is it? Cubed root. So what kind of numbers do we need to pick? Numbers that we can take the cube of. Okay, so let's see. Negative 8 works because the cubed root of negative 8 is negative 2.
Oh, yeah.
Negative 1 works because the cubed root of negative 1 is negative 1. The cubed root of 1 is 1, and the cubed root of the 8 is 8. Now, are those the only things we can pick? No, but they're the smallest ones we can. So that's what we're going with. The easiest, smallest. Now, yesterday we couldn't do negatives because that was an even root. And when we take an even root of a negative, we get an imaginary. But today we're taking an odd root. And when you take an odd root of a negative, you just get a negative. Because a negative times a negative times a negative is a negative. All right, so the first one has not been translated any, so we're going to start off there at 0, 0. And then we're going to apply these moves. These are moves from the translation point. So I'll go left 8, down 2. Left 1, down 1. Right 1, up 1, and right 8, up 2. The reason I make these moves is because negative 8, the cubed root of negative 8 is negative 2. The cubed root of negative 1 is negative 1. The cubed root of positive 1 is 1. And the cubed root of 8 is 2. That's where the moves come from. They come from the function. So then we'll do our little squiggle. Now it looks like, kind of like I took a cube and just twisted it, doesn't it?
Sideways cube.
It is, like a sideways cube. A cubed root is like a sideways cube. Now, because I can take the square root of negatives, I don't have a restriction on my x values. That domain goes forever left and forever right. So negative infinity to positive infinity, right? All right. Now, this one, when I don't shift it, when it's not shifted up, down, left, and right, this one does have symmetry, unlike yesterday. What kind of symmetry? Odd. It has rotational symmetry about the origin. Now, the second one shifts it. How's it shift it? Up 2. And when we shift it up 2, it no longer has symmetry about the origin. So, no more odd symmetry. But we do the same thing. Cubed root of negative 8 is negative 2. Cubed root of negative 1 is negative 1. Cubed root of 1 is 1. Cubed root of 8 is 2. My little sideways squiggle just shifted up 2 units. All right, what would this one do? Down 3. So guys, once we figure out the moves, everything else is the same. So left 8 down 2, left 1 down 1, right 1 up 1, right 8 up 2. There's my squiggle. Sideways squiggle shifted down. So same as yesterday, 0, 2. Same as yesterday, 0, negative 3. Same as yesterday, 0, k. All of it's the same. Transformations work the same no matter what function we're using. So we're not going to fill out this whole thing. We're going to skip, and do number 18. Let's go straight to the examples.
Sounds good.
Okay, so what do we look for? First thing we look for is type of function, cubed root. So we had to pick those numbers we can take the cubed root of. Cubed root of negative 8, negative 2, negative 1, 1, 2. Okay, next thing, just like yesterday, where's the translation point on this one?
Positive 2,
Good.
negative 3.
Positive 2, negative 3 is right on it. Positive 2, negative 3, plot that point. Now, these are normal moves for a cubed root, but this one has a 3 out in front.
So I mean you multiply the -2, -1, 1, and 2 by 3.
You are so right. You could teach this lesson.
Maybe you should.
That is exactly what we do. These moves get multiplied by that 3. So, we go left 8, and then we go down 2, 4, 6 because of the 3. And then we go left 1, instead of down 1, we go down 3. And then we go right 1, and we go up 3. And we go off the charts, and we could go up 6. I'm just kind of guessing. It's somewhere around there. I don't know. Now, this point that I just guessed on, you don't even have to draw. So the points that fit on the graph, please graph them. The points that don't, we don't really worry about so much. Okay, so it goes something like that. We've already talked about there's no restriction on the domain. It goes left forever, it goes right forever. So what would the domain be? That's right, negative infinity to positive infinity.
Same thing with the range.
And the range is the same.
Dude, I know this.
Now, these functions will either be increasing or decreasing. And this one goes up from left to right. So it increases over the entire function. No decreasing. I see one intercept, x-intercept right there. It's the point 3, 0. Now, the y-intercept, it doesn't really look like it crosses perfectly. So I have to come back up here to the equation. And what do I plug in for x to find my y-intercept? 0. So if I plug in 0, I'm going to get 3 times the cubed root of 0 minus 2, which is -2, minus 3. Well, now with this, there's not a whole lot to do. All I can do is take the cubed root of the negative, because a negative times a negative times a negative. We don't leave a negative under an odd root. You actually bring it out. So this y-intercept is this crazy looking number. -3 cubed roots of 2 minus 3. Usually when you plug in 0, there's not a whole lot of math to do. So it kind of ends up being just that goes away. Now, as x approaches negative infinity, what is the function doing? It's approaching what? Negative infinity. So it's going down on this side. And what's it doing on this side? Going up. So positive infinity over here. Alright, so here is my point where it starts to move above the x-axis. So it becomes positive at 3, and it stays positive. And it was negative before we got to 3. So from negative infinity to 3. Now, if it gets shifted left, right, up, or down any, it is neither. It has neither even nor odd symmetry. Okay, I want you to try the next one. And I want to walk around and help anybody that has any questions, and then I'm going to put the answer up in just a minute. And as soon as you're satisfied with your understanding, you can start your homework.